Hello everyone. In this lecture, we are going to study about the convolution theorem and finding the Laplace inverse by using it. Now, the Laplace inverse by convolution theorem is the Laplace of integration 0 to t f1x f2 t minus x dx will be equal to f1 function of s f2 function of s. But we are using the convolution theorem in the inverse, so for us, the convolution theorem is Laplace inverse of two function in product if the function of s, f1 and f2. Then the Laplace inverse of this is equal to a integration from 0 to 1, 0 to t for f1x and f2 is x is replaced by t minus x. This f1 is the Laplace inverse of fs, and for the second Laplace inverse is f2. We replace ft, for this we get ft, and t is replaced by x. For this we get ft and t is replaced by t minus x. Then we have to integrate for 0 to t. This is the convolution theorem. Application of convolution theorems are: it is used to find the solution of differential equation, it is used in signal processing, density modification, automatic scattering factors, diffraction from a lattice, and many more. Now we consider one example which we are going to solve by convolution theorem. Laplace inverse of 1 over s square plus a square. This is just a simple example which we can also solve by the property of Laplace inverse of fs over s is equal to integration 0 to t ft dt, which we already solved in previous lectures. But over here we will solve it by using convolution theorem. So we can say that Laplace inverse of 1 by s into 1 over s square plus a square. So we find that this is f1 of s, and we consider this as a function 2 of s. Now the Laplace of function f1s, Laplace inverse, that is Laplace inverse of 1 by s is equal to 1. Similarly, Laplace inverse of f2s, that is Laplace inverse of 1 upon s square plus a square. To convert this into a formula, we just multiply by a and divide by a. We will get 1 by a. We are just taking these part, considering these part, we get 1 by a into sine 80. So this is our first function, this is our second function. Now by using the convolution theorem, according to convolution theorem, Laplace inverse of f1s and f2s is equal to integration 0 to t. For first function we replace f1 with x, and second function we replace t minus x and dx, integration with respect to x. So over here this is f1t and this is f2t. So by using the convolution theorem, Laplace inverse of 1 over s into 1 over s square plus a square is equal to integration 0 to t. For first function, this is the function of t. If we replace, this is a function of t, how that f1 is a function of t is equal to 1. That means t to the power 0 is multiplied. So f1 of x is equal to 1 into x to the power 0. So it will be just 1 into x to the power 0 into a second function, this f2x is replaced by t minus x. So we are replacing the t with t minus x. We get 1 by a sine t minus x a dx. Now the integration 1 by a integration 0 to t 1 into sine t minus x a dx will be equal to integration of this with respect to x. We get 1 by a is common. For the integration of sine, we get cos at minus ax, and because it is an integration with respect to x, so minus 1, and the limit is 0 to t. Now 1 by a, and substituting the limit, or we just interchange the limit of cos at minus ax, and removing the negative sign, the limit will be t to 0. Now the finally 1 by a, substituting the upper limit in x, we get cos at minus, now substituting the upper limit in this x, we get minus cos at minus at, that is cos 1. So this will be 1 over a cos at minus 1, because cos 0 is 1. But when we integrate this with respect to sine, one more a is over here which is missing, so it will be a square. So this is the solution for the given problem, which we can solve by using the formula. The formula is Laplace inverse of fs upon s is equal to integration 0 to t ft dt. Over here fs will be, and the problem which we have considered is 1 over s into 1 over s square plus a square. So finally this is the fs. So Laplace inverse of 1 over s square plus a square will be 1 by a sine at. That means we have to integrate sine at with respect to 0, limit for 0 to t. We will get the same answer. Now we consider one more example, Laplace inverse. Find the Laplace inverse of s square upon s square plus a square into s square plus b square. To use the convolution theorem, we can say that Laplace inverse of s upon s square plus a square and s upon s square plus b square. So this is the first function f1s, and this will be the second function f2s. Now Laplace inverse of f1s is equal to Laplace inverse of s upon s square plus a square, that will be equal to cos at, and Laplace inverse of f2s is equal to Laplace inverse of s upon s square plus b square is equal to cos bt. So this is our first function f1t, this is our second function f2t. Now by using convolution theorem, according to convolution theorem, Laplace inverse of f1s into f2s is equal to integration 0 to t. For first function, we just consider f of x, and for the second function we just consider t minus x and integration with respect to x. Now the Laplace inverse of f1s and f2s will be equal to integration 0 to t for first function. For this value t is replaced by x, and for this function, second function, t is replaced by t minus x. So this will be equal to cos ax and cos bt minus bx and dx. Now to integrate this, we just use the formula of 2 cos a cos b. That means we have to multiply by 2 and divide by 2. 0 to t cos ax cos bt minus bx dx. So we use the formula 2 cos a cos b, that will be remaining 1 by 2 is common. Integration is from 0 to t, and the value will be cos ax plus bt minus bx plus cos ax minus bt plus bx and dx. Now we just integrate it, we will get 1 by 2. Remember, we are doing integration with respect to x, so the value will be 1 by 2 sine a minus bx plus bt, and we are doing integration with respect to x, so it will be divided by a minus b. For second part, sine a plus bx minus bt upon a plus b for the limit 0 to t, and we have to put this limit for this x. So you just calculate by substituting the upper limit and lower limit. I just recommend you that first you have to substitute the complete upper limit minus the complete value of lower limit. Most of the time substituting this limit will create a problem for the students, and their answer will be wrong from this part onward. So you have to find out the correct answer for this problem. Now, because the problem which we discussed is Laplace inverse of s square upon s square plus a square and s square plus b square, can we say that this will be just s? If it is just s, then the problem will be s upon s square plus a square into 1 over s square plus b square, whether you take this as a f1 of s and this will be as a f2 of s. If someone from you just change the value, someone is having just 1 by Laplace inverse of 1 upon s square plus a square into s upon s square plus b square, and this will be f1s and this will be f2s. The answer will be same. If someone from the audience will consider s along with this, it is okay, and someone if considering the s along with this part, it is okay. You just have to implement the convolution theorem. Even if any one of you will consider this as a f2s, as this as a f1s, the answer will be same. Interchanging in f1 and f2 does not affect your solution. So to make this concept of convolution theorem clear, I am just recommending you to find the solution of this Laplace inverse by using convolution theorem. Laplace inverse of s square upon s square plus a square whole square. We just split it into two parts for the solution. Second is 1 over s square plus a square into s whole square. Third, 1 over s plus 1 Laplace inverse 1 over s plus 1 and s square plus b square. You just have to find out the solution of these three questions by using convolution theorem. Thank you and have a good day. Stay home, stay safe, and for any doubt and any query, please contact your concerned class faculty in your doubt session. Feel free to contact them.